Okay, so we chose this title for the talk, very deliberately, right? Because everybody talks, and probably the most over-abused word is AI at edge, right? Nobody understands what it is. So we chose these words very specifically to say that what we're talking about here today is how do you rapidly, so real quick, scale AI, but in our case, it's actionable insights, right? So how can I take make decisions at the edge, but every time there is an interaction. So if you have somebody interacting with your business, how do you make those decisions? The mic's not on? Oh, okay, all right. So maybe I should.
Can you turn the sensitivity?
Okay.
Okay.
So maybe I'll use this. How's that? It's a little bit easier. So what we embarked on was how do we do that at scale, right? So that's what we're going to talk about. How do you drive actual AI decision making? So let that sink in, to the edge, right? Not do the inference. The typical approach right now is what? You bring in data, it all goes to the cloud, sits in your data lake, you train the models in the cloud, you do your inference in the cloud, and then you push decisions down, right? And the problem with that, it's stale data, doesn't take advantage of it. And what we want to show you is how we've done that. You'll notice three things here: Intel, Scale, IBM. So the three companies came together. And specifically, I'm Mahesh from IBM. And
Sean Williams from Intel.
okay, perfect. So you can read more about us in wherever you can find us. So let's go to the next page. All right. So here's a set of use cases that we just pushed out there to kind of make you think about AI at edge and what does that mean, right? So if you look at, for example, you're doing frictionless checkout, right? Or stock out monitoring. By the way, stock out monitoring, which means that you've run out of stock, costs companies, typically retailers, between 6 to 8% of lost revenue. Think about that, right? $100 billion company, each percent is $1 billion. Right? It's big numbers, and they're losing that every year easily, right? 6 to 8% just on stock out monitoring, all right? So, and all of this require you to bring in data that's not only sitting in your cloud, but getting generated on the fly, right? Think about you're walking out through the checkout counter, frictionless checkout, etc. There's potential of shrink. They call it shrink. Fraud detection. You take two items as one, etc. You check out the wrong thing. Think about personalized promotions. How do I give you personalized promotions if I don't know your buying behavior, right? Your buying behavior is what's happening now wherever you're interacting. Think about buy online, fulfill in store. So that all of that journey takes you from online to store to fulfillment or delivery. Each of those points of interaction, how do I make a decision, right? So that's what we're talking about. Go to the next one. All right. So what are the big problems here that we're trying to solve? So 4 problems. One is scale. Okay? Just to give you the idea of scale, 3,000 stores. Each store has an average of 10 checkout, self-checkout or person checkout, 30,000 nodes, edge nodes. Right? With actual applications, with actual AI being put there. Scale is really, really big out here, right? So as soon as you get to retail, we're talking about large numbers, right? And then you throw in warehouses and trucks and delivery trucks and all that, and the scale is even larger than that. I'm just giving you one component of it, right? Second is heterogeneous nature. So the AI and the applications that you're pushing out and want to do inference at the edge, they are all different. Some could be for security. Some could be for looking at shopper behavior. Some could be for being able to manage how to increase during Black Friday, which is coming up pretty soon, going from processing 30 orders an hour to 60 orders an hour, 100 orders an hour, right? Because if you don't process that many, lost sales again, right? So big impact to business. Third is data gravity. We want to take action when the data is observed, right? So if you cannot do that, or as the data is being generated, I want to be able to take data, apply it, and do, make certain decisions based on it. And finally, constrained environment. Every single place that you go to in retail has a totally different network environment. Sometimes they have to operate in disconnected mode. There's all kinds of ranges. So we need to get from, the word now in the industry, and, probably you've heard it along in this conference too, is first it was DevOps, then it was DevSecOps, and now it's DevSecNetOps, right? Because you have to do it at the level of an application. It doesn't matter that you have operations across everything. But if I take an application and I can ensure that I can provide you security, I can do operations against it, I can do network slicing, bandwidth, give you network assurance against it, now you're starting to get somewhere, right? And if I can shift left, that takes away the burden later on, right? So I don't have to do it in the large scale, right? Okay, thanks. All right, so what we are trying to do is address, we thought like, well, what better way to start than just doing visual AI, right? If I can do camera-based AI, all the other stuff, which is sensor-based, or people-based or app-based, is pretty straightforward, right? If you can do the most difficult part, which is video, apply analytics against it, then every other model will apply. And by the way, we found the 7 S's here, right? So you can do safety, security, spillage, spoilage, stock out, monitoring, I should have said monitoring, stock management, sensing demand, all of that can be done through video analytics, which I'll show you. And the way we're addressing the 4 problems that I just mentioned earlier, scale, heterogeneity, data gravity, et cetera, is by ensuring that instead of going with siloed proprietary technologies, how do we give you a platform based on open standards, of course, commercial versions of open standards, so that we can do this in a consistent way. I'm not handcrafting a particular thing on security that doesn't apply somewhere else, right? Because otherwise it doesn't make sense, correct? And the way we're doing it is primarily on, and what we're showing you today in this project is how can we leverage Open Horizon, which is, it's basically an application management at scale. How do I bring applications to the edge, manage all these applications, manage AI models, manage data, et cetera, at scale, so in terms of deployments, and then a bunch of, and being able to securely onboard all the devices, and then a bunch of camera management services as well as AI model services. So if I can give you that framework, then what you put on it as a particular application or AI model doesn't really matter, right? I mean, I hope you're following or get the drift. All right, so just very quickly, these are actual things we've done before. So just very quickly, you can do customer insights in terms of demographics, queue monitoring, being able to manage checkout, so make sure that everything is going okay. There is, hazards, restricted area monitoring, customer journey, et cetera, right? So I'll just show you a couple so you get to see what the video analytics are. So this one is about scan avoidance. This is very typical. What typically happens is that it's a siloed thing that sits on top of the device checkout, and it's monitoring whether you're doing self-checkout or it's a person there. It's monitoring, making sure that you're not going through the scan, so scan avoidance, or scanning 2 things at the same time, or scanning. So you can see that this is very, you can apply visual insights into making sure that that doesn't happen. Let's go to the next one. And this one is basically what you're doing is doing a heat map of the customer journey. This is very good for sensing demand. How do I sense where each of these, where people are, how much dwell time they're having, and then use that as the way to sense demand and then go from there. Okay, perfect. So today we're going to talk about safety because it's a little bit easier to do it in our labs. You know, people can wear hard hats, etc. So what we're going to do is essentially be able to find for everybody that's walking through a restricted area whether they're wearing proper personal protective equipment, right? Vests, hard hats, gloves, etc. Right? Very useful in terms of being able to do, you know, either warehouses or otherwise. So let me get to the overall implementation and then pass it off to Sean to get into a little bit more detail. So I'll go right to left because the right part is the application side, and then as you go to the left side, you get into the edge nodes, right, and where all the action happens, right? So the top part here is just any proprietary way of training models, right? So we just happen to choose, in this case, IBM's Maximo Visual Insights. It's a way to train your models, okay? So that's the top part. The middle part there, which is the Maximo Application Studio, is sitting there to basically collect the data that's coming in, and then use that as the basis for creating the actionable insights, right? So there's the monitor piece. It goes through the monitor, comes out into a dashboard. You can take some action against it. And then, so those are the application side of the equation, okay? The rest of it is how do you support now that particular set of application, AI-based application, running on the edge, right? So the first part is how am I going to deliver all these services, microservices or otherwise, onto the edge nodes, right? So we basically use the Open Horizon, in this case, manifested in IBM Edge Application Manager. So there is a management hub there, which is sitting on this side of the equation. And then, you know, it is able to take all the services and essentially make sure that it can get deployed in a policy-based way. So you define the policies, you define the dependencies of the applications, and then it gets put out into any kind of edge configuration. So it doesn't matter what the edge node is, whether it's a clustered environment of Intel NUCs, as we're showing here, or it's a single chassis edge node, right? That doesn't really matter. And we can basically manage all the way up into that edge agent, right? So the second part is, of course, the actual models themselves. So the models are being pushed into this Intel Edge Video Analytics microservice that's based on OpenVINO, and we're taking a lot of the models that are built proprietary kind of software, but then being able to take those models and convert them into OpenVINO compliant models and then be able to run them there, okay? And then, of course, you know, take over cameras, et cetera, as we go through. So just to summarize, the three main kind of open source capabilities we have here is one is Open Horizon, along with something called Secure Device Onboard, so that you can onboard devices very quickly. We've got a set of EdgeX services that are shown in purple, and then, of course, the OpenVINO open source kind of projects out here. And, by the way, we are doing this in the context of what's called Aura, which is the Open Retail Reference Architecture, yet another open source project. Okay? All right. So, Sean?
Okay. All right. So, so now I'm going to get to actually some of the management of the camera and the inferencing. So, kind of the AI that's underneath the hood there. Oops. So this is the architecture that Mahesh talked about, where you have the purple boxes that identify with EdgeX. So these are the components that actually provides an open source framework to consume data that's ultimately coming from our video inferencing engine with the inferencing results. On the left-hand side, you see is kind of the core services there. One of the newest contributions to EdgeX is the OnVIF camera microservice. This allows for the connectivity of network cameras at the edge. And so this allows the translation. I'll show you how EdgeX can abstract out for simple RESTful API calls to do some commands and controls of cameras. Say, for instance, if you want to do a PTZ, you want to pan left. That's an API call, but there's a SOAP translation that's going down to the actual camera. So, yeah, it's actually SOAP that's going to the. So, thank you. That's the response that we want, right? So you want just a simple API call here that says I need to do a post call of PTZ, right? And so that actually will go down to the core service of EdgeX command service. It'll say, okay, I need to actually forward this API call to the camera microservice on VIF. Then that's translated. There's a bunch of handshaking messages with SOAP, right? And it actually controls the camera and tells it to pan up or down. And so you'll see kind of through the animation here, and then eventually the camera will go up and down. And that, it's simple but powerful, right? Because you don't want to actually have to start looking at SOAP messages. Or you'll see kind of one of the takeaways that we talk about is that depending on your company, you don't care about this, right? You want the data. You want to start developing applications at the top layer. But this is necessary. So kind of like the combination and collaboration with us is that we're giving you 0 to 25%, 0 to 50% of your solution stack where you're actually communicating to those devices at the edge, getting the data, getting the inferencing results, and then you can make the magic happen based on your use case.
Yeah, and by the way, even though we're talking only about cameras here, the EdgeX services are such that, we're going to be, or Intel's going to be working on making sure it works with other sensors, right? Think refrigerator sensors, et cetera, whatever, location sensors, so that this is going to be a set of capabilities that allows you to take anything that's generating data at the edge to be brought into the consideration.
Yeah, exactly. One of the buzzwords that we hear all the time is data fusion, right? So EdgeX supplies these connectors. That's one of the advantages of EdgeX is these tried and true plug and play connectors. It has a connector for RFID sensors, LLRP. So you drop that connector on, now you're actually talking to a camera, and you have another connector, LLRP, that's talking to an RFID sensor or Bluetooth. And now you get that nice data fusion to make some kind of inference of what's happening at the edge. So that's the management part. And then the inferencing part here is where the RTSP stream is then sent from the camera to the Edge Video Analytics microservice, which is then the analytics on that stream is performed based on OpenVIDO, based on that model. And once those results come back in, then it's using MQTT, and those inferencing is based on MQTT device service, then put back on the bus to be consumed by any other microservice that's talking to EdgeX, or pushed up to, for whatever use case, up to the cloud, or to some monitoring system or graphical UI that would show some kind of alerts or some inferencing based on those results. Yeah. So that was the animation here, and a lot of times people say, okay, especially when we do this talk, is that's just slideware. Do you actually have it working, right? and this video is actually a deployment into the Dallas Center for IBM of this software stack using the components that we talked about, Open Horizon, IAM, and the EdgeX services along with Intel's Edge Video Analytics. So I'll try to run this a little bit. What you'll see, and I may give some color while it's going, but what you'll see is just the easy arrow pad that kind of says, I'm gonna push this arrow, and then that's the actual initiation of the API call you'll see in the log. Then you'll see the camera going back and forth, up and down. You'll also see the start of the pipeline for DL Streaming Pipeline Server. Those are the models there. And then on the left-hand side, you'll see the collection of the inferencing results. Again, just a simple UI just to visualize what's actually happening. So that's a selection of which cameras that are deployed in the Dallas Center. So it's going to select one of those cameras, initiate a pan left. You'll see the API log here. It's kind of fuzzy, but you'll get the concept. That call is in actually making the control to the camera on the right-hand side. Again, easily abstracting out instead of actually SOAP messages, some simplicity for your application stack.
Yeah, and what was shown there is the idea that you can connect up different models to different cameras pretty straightforwardly, right, with all of this. So you don't have to have the same model everywhere, but as long as you understand like which models you want to apply and do it on the fly as well, right? So you could think about being in a store where in the morning time you're doing checkout monitoring. When the store is closed, you can push AI models that are doing security monitoring, as an example.
And so what you saw there is just, again, open source components. Even the UI, that camera management UI is up on EdgeX, and we have a list of all the links you can get. But none of this is just, proprietary to us. Obviously, we're talking about open source, but some of these things, just even the actual UI that does the orchestration, that's in the examples repo of EdgeX, so that's consumable there as well.
Yeah. So yeah, and so just very quickly on the IEM or implementation of Open Horizon. So essentially, we've got a management hub. The basic idea is that how do you take the set of microservices that you want to deploy, so the app side, and you do the AI models independently, right? So how do you take those two components and define for the microservices the dependencies through a policy? Once you've defined the policy, and of course you've got security in place, et cetera, then what happens is that the management hub, along with these edge nodes, so you're talking about 1 to 40,000, right? That's the scale of what you can do. So what it does is that then it manages those microservices being pushed out and its life cycle through that policy base. So it's all automated. You don't have to do anything different, right? And we'll show you an example of a complicated set of microservices. So think about if I'm pushing an application, which is an AI application, it's not going to be just one. It could be like 10, 15, 20 microservices all having to work together. What happens from a software development perspective when one of those microservices change? New version comes out, right? Someone has to manage all of that deployment now, again, to potentially tens of thousands of nodes, right? So you make a change, the IEM will take care of how do you make sure that you're handling that in an appropriate fashion, right? And of course, because it's a commercial version of Open Horizon, we have things like, container registry, which can be, any type of container registry. So we don't really care what it is. You define it, whether it's enterprise level registries or otherwise. And you can see that because it's a commercial implementation as well, that we're addressing all of the people that are involved in delivering an AI application, right? From the developers, and we have separation of concerns. So you have dev on the top right, you have operations, with the administrator, et cetera, defining the deployment policies. And then once those are done, then everything is managed in an automatic fashion, right? So for this example, Sean.
So to Mahesh's point, as far as, I'm not sure why the background changed, but as far as the deployment policies, again, here's the software stack we just talked about, right? It's very simple, and we got the color coordinating right here. But this actually illustrates the complexity of the deployment dependency policies. So all the lines are what microservice depends on the other. So back to what Mahesh was saying is that if you make a change to console, and you want to update console, based on this deployment dependency policy, anything that depends on console will also get that update, ensuring that you don't have that breakage in your architecture or in your software stack.
Yeah, and I just want to say one other point here is that, just to make drive that point home, right? The AI models and the pipelines are being managed independently of these applications, right? So they're not tied together. So you can continuously manage those separately, so you can push and dynamically. That's the other point, right? So you can just say policy based on this time at night, as an example that I gave, throw in the security AI. Okay. Yeah, absolutely.
You don't push,
Pull. Okay.
right?
Yeah.
Just for security reasons, the agent recognizes
Yeah.
it and then pulls it down.
Right. Correct. Thank you for the correction. Yeah. All right. Yeah. All right. So what have we? Somehow that's strange.
Yeah. Those are supposed to say key
Yeah.
takeaways.
Yeah. Okay. So this is our key takeaways from this thing. So from this project. So the first one is that we're delivering a open source AI at edge platform. Think of it that way, so that we can enable a lot of different types of edge use cases, right? Whether it's based on devices that you're collecting data from, or the AI models that you're pushing in, or the applications, or the infrastructure. So you can build up whatever edge node you want, wherever it's sitting, and then be able to kind of push these onto those devices, whether at the Mac or the actual location itself, it doesn't really matter. The second one, maybe you can take
Yeah,
that.
another thing, a couple things to highlight is going back to the plug and play of the tested
Yes.
device connectors. Again, going back to some of the goodness of EdgeX is those tested and validated connectors, as we talked about. So now we have one that's on-VIF camera connector. We just contributed a USB camera connector, and already up there is a LLRP one for RFID sensors. All this is tried and true for that simple platform to create some commonality, as you were, for collecting the data from various sensors, putting that on a certain bus, and then subscribing to those topics or communicating with those other microservices to get that data to develop applications on what we call the northbound.
Yeah, and then the second one is how do we accelerate software development, right? So,
This goes back, right? So we just talked about as far as sometimes analogy is the blocking and tackling. So again, depending on your company and your use case, you really don't care about how you get the data. You just want the data. You want to be translating stuff from SOAP to whatever. Well, this gets you from 0 to 20, 0 to 25, 0 to 50%. Whatever that case may be, for you now to be collecting that data, subscribing to that topic, and then performing or developing the applications that can address the particular use cases.
yeah, and this, our idea here is heterogeneity, scale, right? I mean, that's basically it, right? So we're trying to make it a lot easier through these toolkits that are available, as well as, not having to handcraft. I spent a lot of years in Watson IoT, when we had that division going, and we spent a lot of time trying to handcraft our solutions based on the particular IoT, based on this IoT gateway, the sensors that are provided, what message streams are coming through. This makes a lot easier in managing the sensors on one side and the cameras, et cetera, being able to push the AI models down, et cetera, right? And the applications. And then the final part is that you're doing policy-based automation, which means that you can manage a large number of edge nodes very easily, scale it up to 40,000, as I said, and then you have a lot of flexibility in the life cycles of the AI models, et cetera. Is that it? Yeah. And then if you want to get more, we've created a small place where you can enter information and it'll come to us. So can you go to the next one? It's kind of, oops.
I don't know why they're
Yeah, I don't know what's
rendering
happening with the thing. It's kind of strange. But we wanted to see like what your, if you had any use cases that you were thinking about for your customers or whatever that we could talk through, or any questions that we can take at this point. Oh, we were crystal clear, I guess. Or thick as mud.
The version of what you talked about, it is in below A, John and IBM, and then from the
Yes. Yeah, yes. So John and is part of the same team that we're working with. And then, by the way, for just to make a plug, most likely this is going to be the case, but there's a keynote with Rob High tomorrow, and what he's going to be hopefully talking about is a piece of work that we're doing around showcasing how to do open source networking in this context, right, with 5G, et cetera. So that's another area that you can
And also, we're part of the LF Edge Solutions Showcase. So, of the 4 booths with retail, manufacturing, and other ones. If you have any other questions, you can see the slide deck and us posting up for more in-depth questions down at the LF Solutions Showcase booth.
Yeah, and I just, if there are no questions, question, perfect, yeah.
Many thanks for the great presentation.
Yeah.
About Open Horizon in this case. I will give a lecture later on how Open Horizon can be used in agriculture.
Yeah.
I think that is a very good use case to see, like IT sample data
Yep.
can implement it in a, and more edge devices can deploy
Yeah.
and so on.
Yeah, so agribusiness is one of the big areas that we're focused on. So I'm actually part of the distribution industry, and agribusiness comes into ours. And one of the areas that we've done a lot of work, with sustainable farming, a lot of other things, is all based on that, right? Because a lot of the work that came from it was by taking geospatial data along with weather data, and then being able to correlate that with soil data, and being able to essentially, achieve the use cases that we're talking about.
Yeah, we're doing a lot of that with Telus. So I
Yeah,
can
sure. Yeah,
at the TN4 with this type of architecture, IBM got the award
yeah,
for recognizing weeds in agriculture. So
yeah.
they're applying everything that they're using the cameras to identify weeds.
Right. Yeah. So and then there's like automated like robots doing the work of doing managing that, so that because once you get into this area, what you quickly realize is that first, of course, the step is how do you get data to make those actionable insights. The next step is how do you optimize against that, and optimization typically means that you've now identified the patterns that you can now start to automate it very quickly, and then you're in good shape from that point onwards. So I want to, oh yeah,
Somebody who doesn't have a agriculture field,
yeah,
just wants to tinker,
yeah,
what would be a good first project for this? Like, I don't have a store to go and put a bunch of cameras above me.
yeah, yeah.
Learn and tinker with it.
Yeah, so the best way to tinker about it is that if you look at many of these training, model training capabilities, it's basically you upload a set of photographs, of, let's say, hard hats, etc. You train the models very quickly, and then with just your, phone, etc., you can actually go around and start to play around with it, because your phone is an edge node, right, essentially. And it's got enough to run on the edge node, as an edge node. And there are, like, if you go to ibm.com/developer, so you can get a lot of tutorials and do-it-yourself guides where you can come up to speed with it. And it gives you access to the underlying technologies very effectively. The same thing is available from...
Yep, correct. So if going to this will give you some links. And there's about a 10-minute YouTube video. If you just do a search on YouTube of EdgeX OnVIF camera device service, there's a 10-minute video showing you how you can download the Docker images, configure what's called a TAPO camera with IP, with a network camera. And then that UI that you saw there, you would go to it'll show you how to pull down that camera management UI, all from EdgeX, from their GitHub links right there. And you can get that up and running in roughly 10 minutes just by following that video for OnVIF. So you can get that, kind of what we saw at that last part with the UI, and getting those inferencing results, putting back onto the bus, and controlling those cameras right there. So I don't think legal can get me to say that one.
And then you can get some, sensor toolkits. They're very small sensors. Yeah, or even Raspberry Pi, but there's some sensor toolkits which are very small. Gives you like 7 readings, of like temperature, et cetera, and you can use those as the basis, put it in your, at your home, and you can do a lot of things, like monitor humidity and take some actions against it, et cetera, right? Temperature. Yeah, cat's litter box. Yeah, point a camera at it, do some things and say, give me an alert when, actually, we've done things on smell as well, but that's a different story. So I'll leave you with a couple of data points, right? So first data point: data scientists spend, they say, 80%, and I would say more than that, of their time doing what? Chasing data, right? Because the current cycle, AI life cycle, is I go grab all my data, put it into a data lake, and then I go and do things, right? So they keep that in your at the top of your mind, on one side of your brain. Second part is that every store, retail store, on average generates, on average, per day, 40 terabytes of data. Right? And if you go to most retailers, they say, we have no idea what's in that data because it's all being left behind. I take a video of something, something happened, I took some action, but all that value is gone, right? And you cannot, you don't have enough money to push 40 terabytes times 3,000, into Azure or AWS or wherever you're putting it. You go broke, right, as a company, right? Not only in bringing the data in, but especially using the data, right? So there's a lot of value being lost just in that, right? And then the last part is that I would say that the differentiation for a lot of businesses is all about this kind of AI at the edge, real AI at the edge. If you don't have it, you've lost your differentiation. Then you just become just a regular. So I'll give you a quick example. Personalization, or what happens when you go to the grocery store? You buy a product, you get a coupon, right? Which is exactly the opposite of personalization. It should be that if I've, based on my past behavior, I should have something that says, here, by the way, you are coming to the store for, Thanksgiving or whatever it is, I'll give you a coupon based on your past behavior that allows you to buy everything that you need at a discounted rate, right? So it's very difficult to provide that kind of very precise personalization and differentiation without AI at the edge.
And one of the other things that kind of goes without saying is that if you have a proper software stack like this and you're putting all these open source components, AI at the edge is for any vertical, any use case. Yes. Although this is retail, it could be for agriculture, it could be for industrial manufacturing. And so what we're trying to do is just make that as easy as possible as just changing the model, right? And then your application is what you want to do with the information that comes out of that model. And so that's kind of the other underlying takeaway that we wanted to highlight there.
Yeah. And we continue to do this, right? This is going to be, the way we are thinking about it is this was the start. The next step is to bring in on both sides of the equation. So the infrastructure side, bring networking, bring kind of, which is our next step. Our adjacent step is how do you get management of all of the microservices, so Kubernetes-based orchestration. How do you get that in an open source way? And then continuing along that pathway into operational side of the equation.
Yeah, I think we're a little over, but we'd love to answer more questions. We don't hold you. All right, thank you for your time.
Thank you very much.